8.1 goes over factoring and completing the square. If we look at the first set of examples here, we're just going to be solving by factoring. When we do this, we want everything on the same side as our x squared. So when we look at example 1, which is 3x squared minus 4x is equal to 15, we're going to start this one by subtracting the 15 from each side and setting this equal to 0. So really we're going to be working with 3x squared minus 4x minus 15 is equal to 0. From here, we're going to find the factors when we multiply the 3 times the 15. The reason why you can't factor out the 3 and have it just to be x squared is because you don't have a common factor of 3 or any other term that's a factor of 3 other than 1 within all 3 of your terms. So we're going to multiply the 3 times the negative 15. That gives us negative 45. We want to find the factors of negative 45 that add up to be negative 4. If we had 5 and negative 9, that gives us negative 4. So we're gonna rewrite this as 3x squared plus 5x minus 9x minus 15 is equal to 0. Now that we have 4 terms, we are going to factor by grouping. When we factor by grouping here, we're going to set 2 parentheses around the first 2 terms and then another set of parentheses around the last 2 terms. Between the first 2 terms, the only thing we can factor out is an x. Between the last 2 terms, we can factor out a negative 3. So this factors to be x times 3x plus 5 minus 3 times 3x plus 5 is equal to 0. Your 2 sets of parentheses are the same, so we're going to rewrite it once and then form another set of parentheses with the x and the negative 3. We are solving these, so we're going to set each set of parentheses equal to 0, and we're going to solve. So we're going to have 3x plus 5 is equal to 0, and x minus 3 is equal to 0. We subtract the 5 from each side with the 3x plus 5 is equal to 0. We get 3x is equal to negative 5. Then we divide each side by the 3, and we get that x is equal to negative 5 over 3. For the x minus 3 is equal to 0, we add the 3 to both sides, and we get that x is equal to 3 as well. So you have 2 solutions for this one, the negative 5/3 and the 3. For our next example, we are given a minus 1 squared is equal to 9. For this one, we do have a binomial squared on one side of that equal sign. So if we isolate that binomial squared, we could start by taking the square root of each side. Remember, when you take the square root of each side, your answer is both positive and negative of that radical. So for this, we're going to take the square root of that a minus 1 squared. We're going to take the square root of that 9. The square root of that a minus 1 squared cancels out that power, and you just have a minus 1. The square root of 9 is both positive and negative 3. Because that radical simplified completely, we're going to separate this into 2 equations. We're going to have a minus 1 is equal to negative 3, as well as a minus 1 is equal to positive 3. Move your 1 to both sides of that equal sign. You have that a is equal to negative 2, and a is equal to 4. Next part of our lesson, we're going to be solving by completing the square. When we complete the square, our whole idea is to get a binomial squared that is a perfect square trinomial. So that way you can take the square root of both sides and solve. Now, when we look at some of the first examples that we're going to work with these perfect square trinomials, we're going to be finding the last term, so that C term that gives us a perfect square trinomial. In order to find that C term, you are going to use b over 2 squared. The Same thing that you have here. So, in order to find this, first identify b. b is the term that's in front of x, not x squared, just x. Once you find that, divide it by 2 and square it. Whatever that term is or whatever that number is, that is your new c term. And you'll add that to the binomial that's given to you. If we look at example 3a, we have x squared plus 8x. Our b here is 8. To find c, which is b over 2 squared, we're going to take 8, divide it by 2, and square it. 8 divided by 2 is 4. 4 squared is 16. This 16 gets added to the original part that was given to us. So our perfect square trinomial that we're looking for is x squared plus 8x plus 16. For example B, we have x squared minus 5x. For this one, our b is negative 5. Again, to find c, we're going to do negative 5 over 2 squared. The negative 5 over 2, you cannot simplify any further. So we're just going to square this, and c is going to be equal to 25 over 4. So we're going to add this to the original expression that was given to us, and we're going to have x squared minus 5x plus 25 over 4. For example C, we have x squared plus 4 over 7x. Our b term here is 4 over 7. Again, to find our new c term, we're going to do b over 2 squared. So that's going to give us 4 over 7 divided by 2 squared. Rewrite this as a division problem. So c is equal to 4 over 7 divided by 2, or 2 over 1 squared. When you divide fractions, keep, change, flip. So c is equal to 4 over 7 times 2 over 1 becomes 1 over 2 squared. Your 4 becomes a 2, your 2 becomes a 1, so that's just 2 over 7 squared. 2 over 7 squared gives us 4 over 49. We're going to add this to the expression that was originally given to us, and we're going to have x squared plus 4 over 7x plus 4 over 49. For example D, we have x squared minus 3 over 2x. Our b in this case is negative 3 over 2. So to find c, we're going to do b over 2 squared. That's going to give us 3 over 2 divided by 2 squared. Again, write this as a division problem. So that's 3 over 2 divided by 2 over 1 squared. Keep, change, flip. That's 3 over 2 times 1 over 2 squared. For this one, you cannot cross simplify before you multiply. So multiply straight across. 3 times 1 is 3. 2 times 2 is 4. So that's 3/4 squared. 3 squared is 9. 4 squared is 16. So it's 9 over 16 that we're adding to the original problem. So that's x squared minus 3 over 2x plus 9 over 16. The next part that we are going to be going over is factoring each of these trinomials. These are perfect square trinomials. So when you look at this, you'll be able to take the square root of the last term, that c term, and if you can multiply that by 2, it will give you your middle term. When that happens, you have a perfect square trinomial. So it's just a binomial squared that your answer is. Your binomials that's your squaring will have the same sign between your two terms that your b term has in the perfect square trinomial. So if we look at example 4a, we have x squared plus 12x plus 36. We can take the square root of that 36. It is 6. If we multiply that 6 by 2, it gives us the 12. So this has a positive in front of the 12. Our binomial is just going to be x plus 6 squared. If also you wanted to just find the factors of 36 that add up to be 12, you'd have 6 and 6. So it would factor out to be x plus 6 times x plus 6, which you can then rewrite as x plus 6 squared. If we look at example B, we have y squared minus 7y plus 49 over 4. Now another way of doing this is you could take your b term, which is negative 7, divide it by 2, and square it. If it gives you the 49 over 4, it's a perfect square trinomial. So the only thing you'd have to do is take that negative 7 over 2 squared and put an x in front of it. So it gives you your x minus 7 over 2 to the second power. For example C, we have z squared minus 4/3 z plus 4 over 9. For this one, our b term is that negative 4 over 3. If we were to multiply this, divide it by 2 and square it, this would give us negative 4/3 divided by 2 over 1 squared. This leaves us with negative 4/3 times 1 over 2 squared. Your negative 4 turns into a negative 2, 2 turns into a 1, so that's negative 2 over 3 squared, which is 4 over 9. That is your term. That's right there. So the only thing you'd have to do, look at this part, put an x in there, and then you're good to go. So x minus 2/3 to the second power is that perfect square trinomial factored. Example 5 tells us to solve by completing the square. So when we do this, we are going to isolate our constant term. So in this case, we have x squared plus 6x plus 5. That 5 is going to be moved over to the other side to start. From there, we're going to use that b over 2 squared to find our new c term. And once we find that new c term, we're going to add it to both sides of the equation. And then we're going to factor the left side, add the right side, and solve for our variable. So for this example, again, we have x squared plus 6x plus 5 is equal to 0. First, we're going to move the 5 over by subtracting it from each side. This gives us x squared plus 6x is equal to negative 5. Our b term is the 6th. So to find c, we're going to do 6 over 2 squared, which gives us 3 squared, which is 9. That 9 is going to get added to both sides of our equation. So this is going to give us x squared plus 6x plus 9 is equal to negative 5 plus 9. We're going to factor the left side, add the right side. When we factor the left side, the number or the term that was in the parentheses before we squared it is what we're going to have with our variable. So our variable here is x. That number that was being squared in order to get the 9 is 3. The 3 is positive, so it's x plus 3 squared. Negative 5 plus 9 gives us 4. And from here, we're just going to solve for x. We have x plus 3 raised to the second power is equal to 4. To get rid of that power, we're going to take the square root of both sides. Remember, when you take the square root of that 4, the plus or minus goes in front of your answer. So you have x plus 3 is equal to plus or minus 2. From here, because that radical simplified to be a constant number, we're going to separate it into two equations and solve for both. So this is going to separate to be x plus 3 is equal to negative 2. as well as x plus 3 is equal to positive 2. Move your 3 over by subtracting it from both sides on both of these equations, and you get that x is equal to negative 5 and x is equal to negative 1. For our next example, we're doing the same thing. However, this time we have an a value that's not 1. When you have an a value that's not 1, you are going to have to divide out that a value. So start like you did with the last one. For example 6, we're given 2x squared plus 3x minus 2 is equal to 0. Our constant is not on its own side. So we're going to start this one by adding the 2 to move it over to the other side of that equal sign. We have 2x squared plus 3x is equal to 2. From here, we're going to divide by 2 on each side. This cancels out the 2 in front of the x squared, which is what you need to happen. The 3 divided by 2 is going to stay 3/2 x, and 2 divided by 2 is 1. So we're working with x squared plus 3/2 x is equal to 1. Our b term is the 3/2, so to find c, we're going to do 3 over 2 divided by 2 squared. Remember, write it as a division problem. That's 3 over 2 divided by 2 over 1 squared, which is 3 over 2 times 1/2 squared. This gives us 3 over 4 squared, which is 9 over 16. That 9 over 16 gets added to both sides of that equation. So we're going to have x squared plus 3/2 x plus 9 over 16 is equal to 1 over 1, or 1, plus 9 over 16. In order for you to add those two fractions, it's going to have to be something over 16. So we're going to have 16 over 16. So we're going to factor the left side. The number that was in the parentheses that we squared was 3/4. So this factors out to be x plus 3/4 squared. And then you have 16 plus 9, which gives us 25. Keep it over the 16. From here, you're going to take the square root of both sides. Take the square to the left side, take the square to the right side. It cancels out that power, so you just have x plus 3/4 is equal to, you're taking the square root of both sides, so put that plus or minus in front of your answer. The square root of 25 is 5, the square root of 16 is 4. So it's 5/4. From here, we're going to separate it into two equations. So we're going to have x plus 3/4 is equal to negative 5/4, and x plus 3/4 is equal to positive 5/4. We're going to solve for both of these by subtracting 3/4 from each side. Again, we're doing that to both. So we're getting that x is equal to negative 8 over 4, which simplifies to be x is equal to negative 2. We do the same with the other. Subtract the 3/4 from each side. We get x is equal to 2/4, which gives us x is equal to 1/2. So our two solutions here are negative 2 and 1/2. For our next example, we're given x squared minus 3x minus 6 is equal to 0. For this one, we're going to add the 6 over to the other side. This will give us x squared minus 3x is equal to 6. From here, our b is negative 3. So in order to find c, we're going to do negative 3 over 2 squared, which gives us 9 over 4. That 9 over 4 gets added to both sides of our equation. So we're going to have x squared minus 3x plus 9 over 4 is equal to 6 plus 9 over 4. That 6 is 6 over 1. You have to turn it into a fraction that has 4 in the denominator. So you're going to have x squared minus 3x plus 9 over 4 is equal to 24 over 4 plus 9 over 4. From here, we're going to add the right side. We're going to factor the left side. To factor the left side, look at the term that you squared that was in the parentheses. It's that negative 3 halves. So this factors out to be x minus 3 halves squared is equal to 24 plus 9 gives us 33 over 4. From here, we're going to take the square root of both sides. Take the square root of the left side, take the square root of the right side. Taking the square root of the left side cancels out the power, and you're working with x minus 3 over 2. On the right side, the square root of that 33, you can't do, so you're going to leave it the square root of 33. The square root of 4 is 2. So this gives us plus or minus the square root of 33 over 2. I'm going to rewrite this just that way it makes a little bit more sense. From here, I'm going to add the 3 over 2 to both sides. When I do this, it's going to go in front of that plus or minus square root 33 over 2. So we're going to have x is equal to positive 3 over 2 plus or minus the square root of 33 over 2. Because these have the same denominators, we can write it as one fraction, and it's just going to be x is equal to 3 plus or minus the square root of 33 all over 2. For the next example, we are just solving. We have x plus 3 is equal to the square root of 153 minus x. For this one, you are going to start by taking the square root of both sides, by squaring both sides in order to get rid of that radical. So you're going to put parentheses around the x plus 3, you're going to square it. You're going to put parentheses around the square root of 153 minus x, you're going to square it. The square root to the second power cancels out, where you just have the 153 minus x. That x plus 3 squared is a binomial squared, so you're going to get a perfect square trinomial, which means you're going to have x squared plus 6x plus 9 is equal to 153 minus x. From here, we're going to add the x to both sides. To move it over, we're going to subtract 153 from both sides to move that over as well. So these both cancel. We're going to be working with x squared plus 7x. 9 minus 153 is negative 144. From here, we can use the completing the square method in order to solve this. We can move that 144 over by adding it to both sides. We're going to have x squared plus 7x is equal to 144. From here, your b is 7, so to find your c term, you're going to do 7 over 2 squared, which is 49 over 4. Add your 49 over 4 to both sides of your equation. This gives you x squared plus 7x plus 49 over 4 is equal to 144 plus 49 over 4. You need a fraction with the same denominator as the 4. So you're going to have to multiply that 144 by 4 and put it over 4. So this is going to give you x squared plus 7x plus 49 over 4 is equal to 576 over 4 plus 49 over 4. Factor your left side, add your right side. On the left side, you're going to have x plus 7 over 2 squared. On the right side, you're going to have 625 over 4. From here, take the square root of both sides. This is going to leave us with x plus 7 over 2 is equal to 25 over 2. Because you do not have a radical left over with this, it is plus or minus, we're going to separate it into two equations and solve for both. So we're going to have x plus 7 over 2 is equal to negative 25 over 2, as well as x plus 7 over 2 is equal to 25 over 2. Subtract the 7 over 2 from each side. This is going to leave you with x is equal to negative 32 over 2, which simplifies to be negative 16. And your other one, we're going to subtract the 7 over 2 from each side. The 25 minus 7 gives us 18 over 2, which simplifies to be 9. So negative 16 and 9 are your two solutions. For example 9, we have 1 over x plus 3 over x minus 2 is equal to 5 over 8. Now, I don't like working with fractions as much as you don't like working with fractions, so what I'm going to do is I'm going to eliminate my fractions by multiplying the entire equation by my least common denominator. Our least common denominator here is 8x times x minus 2. So, if I multiply the entire thing by the 8x times x minus 2, we're going to take 8 times x minus 2 and multiply it by 1, because that's what the denominator doesn't have. For the 3 over x minus 2, the denominator doesn't have the 8x, so we'll take 8x and multiply it by 3. For the 5 over 8, the denominator doesn't have the x or the x minus 2, so we're going to take 5, multiply it by x, and multiply that by x minus 2. So 8 times 1 is 8, 8 times x is 8x, 8 times negative 2 is negative 16. The 8x times 3 is 24x. The 5 times x is 5x. 5x times x is 5x squared. 5x times negative 2 is negative 10x. From here, we can combine our like terms on the left side. That 8 plus 24 gives us 32x minus 16 is equal to 5x squared minus 10x. From here, we're going to subtract the 32x from each side, and we're going to add the 16 to both sides as well. This is going to leave us with 5x squared minus 42x plus 16 is equal to 0. Now, the reason why I do this and I don't leave the 16 over to the other side is because you don't necessarily have to always use the completing the square method in order to solve. So if you can take the 5 and multiply it by 16, that gives you 80. If you have factors of 80, positive 80, that give you a negative 42, you can factor this like normal. So we have 1 and 80, 2, 40, 3 does not go into it evenly, 4 goes in 20 times. If these two are negative, it's going to give you a negative 42, which is what you're looking for. So I'm going to separate this and factor it as 5x squared minus 2x minus 40x plus 16 is equal to 0. So I put parentheses around the first two, put parentheses around the last two, factor out an x from the first. For the last, we're going to factor out a negative 8. This is going to leave us with x times 5x minus 2 minus 8 times 5x minus 2 is equal to 0. We're going to separate this even further to be 5x minus 2 times x minus 8 is equal to 0. And then we're going to solve by taking the 5x minus 2, setting it equal to 0, and the x minus 8 by setting it equal to 0. Add your 2 to both sides. You have 5x is equal to 2. Divide each side by the 5. You have that x is 2/5. For the x plus 8 is equal to, x minus 8 is equal to 0, add your 8 to both sides, and you get that x is also equal to 8. So 2/5 and 8. So you don't necessarily always have to work with the completing the square method in order to solve these. If it's easier to work by factoring it, you could do that as well. For the last example in this lesson, we have x squared minus 4x plus 12 is equal to 0. If we solve this by completing the square, we would have to move the 12 over by subtracting it from each side. This is going to leave us with x squared minus 4x is equal to negative 12. Our b is negative 4, so to find c, we're going to do negative 4 over 2 squared, which is negative 2 squared, and that's 4. We're going to add that 4 to both sides of our equation. So we have x squared minus 4x plus 4 is equal to negative 12 plus 4. From here, we're going to factor the left side, add the right side. We have x minus 2 squared is equal to negative 8. From here, we take the square root of both sides. You do have a negative underneath that radical on the left side. We do know that that negative can be represented by an I, so you just don't automatically cancel this out as no solution anymore. You're going to have x minus 2 is equal to plus or minus I square root 8. That square root 8 is 2 and 4. 4 is 2 and 2. You need 2 of the same number, so this becomes x minus 2 is equal to plus or minus 2I square root 2. You want to you want to add that 2 to each side in order to get x by itself. So you have x is equal to 2 plus or minus 2I square root 2. And that 2 that you moved over to the other side does in fact go in front of that plus or minus 2I square root 2.